side equal to the right hand side, then we can say that m is equal to n. Okay, let me move on to some practice exercise to help you guys to get a hang of the log functions and the log formulas. The first technique that you guys need to know in here is how to decompose a log equation, log expression, to make it that way. See, they give you a big log, then you try to break it out to small logs. Especially this part is for those who tend to take calculus, say Cal 1, Cal 2. You need to do like integration, and you learn how to break a log is important. So let me show you. Say I got this. Log base 3 of x to the 7 times y to the 4, for example. And how do I break it out? Okay? I see a product, right? Usually you have parentheses, but later on you don't want to write too much. No need to write parentheses. People understand. Okay? So think of this one is like m right here. This is like m, and this is like n. So log base 3 of m times n. So this is what? Log base 3 of x to the 7 plus log base 3 of y to the 4. You see? The log of the product. If I break it out, it becomes the sum of two logs. It's only happen if you have a multiplication. All right. Now I see log base 3 of x to the 7. What can I do with the exponent? We have a formula that helps us to bring the exponent outside. And this is what? 7 times log base 3 of x. And similarly for the y, I got 4 times log base 3 of y. Okay? So we show you how to decompose or break a big log into single one, smaller one. How about another example? Ln of x to the 7 times square root of x plus 4, for example. Okay. We call it Ln means log base e. Okay. So I see the product right here. It's going to be Ln of x to the 7 plus Ln of square root of x plus 4. Okay. And same thing in here for the exponent 7. I can rewrite it, bring the exponent out, bring the 7 out, 7 times Ln of x. What about the square root? How do you simplify it? And we have a very good invention, really, for the square root. We can rewrite it as square root of x plus 4. We can write it as x plus 4 to the 1/2. Okay? So I can write it this way, Ln of x plus 4 raised to the 1/2. So instead of writing the radical notation, I can express the same thing as the exponential form. Now the exponent is 1/2. So I can write this way. The first part is the same, 7 Ln of x and plus 1/2 Ln of x plus 4. Okay? So in here I'll try to show you how to decompose, how to break a big log up into smaller terms. Try more. How about this? Another one, okay? I'll just choose some exercises from the book. Ln of 6x times square root of 1 plus 3x all over x minus 4 squared. Okay, so what I'm seeing here is we have a log, natural log of base e, and they have some factors of 6 times x times square root, and then divided by x minus 4 squared. Okay, so apply the general formula I show you. Any factor on the top, when you break it out, go with the plus sign. Any factor on the bottom, go with the minus sign. So I got what? Ln of 6 plus Ln of x, the 6 times x, and then times, it's a plus Ln of square root of 1 plus x squared. And we can even use that exponential form right here. So instead of writing square root of x, 1 plus 3x, not x squared, I copied it wrong. 1 plus 3x, okay? You can rewrite it as 1 plus 3x raised to the 1/2, because square root is the same thing as power 1/2. And then any factor on the bottom, you're going to go with the minus sign, so subtract ln of x minus 4 squared. Okay? So I had 3 factors on the top, 6, and then x, and then square root. I only have 1 factor on the bottom, which is x minus 4 with multiplicity 2, so exponent 2. Okay? Now I can even go a little bit further. I can bring the exponent down, so this is ln of 6 plus ln of x plus 1/2 ln of 1 plus 3x, and then minus 2 times ln of x minus 4. Okay? Okay. And then there's another type of exercise that you will see in your homework. This is the opposite of what you learned right here. Now we're going to give you a bunch of small logs, and we ask you to put them all together. Okay, so let me find an example. I'll show you. Oh, okay, choose the hard one, big one. Or maybe we can start with something easy first, and then we'll get to a big one later. So, more examples. Say if I have this. Log base 2 of 3 log base 2 of x plus 4 log base 2 of y minus 2 log base 2 of z. Now I got 3 logs, okay? And I want to put together as one log because they're all the same base 2. So first of all, we try to bring the exponent in. The first term is the same thing as log base 2 of x cubed, right? The 3 number outside, bring it inside the log, becomes exponent. Backward, exponent inside the log, bring it out, becomes a factor outside the log. And similarly, this is log base 2 of y to the 4, and then minus log base 2 of z squared. Z squared. Okay? Now I have a combination of 3 logs with the same base 2. So if you put them all together, if you have adding, it's going to be on the numerator. Subtraction is going to be on the denominator. So it's the same thing as log base 2. I have a fraction. Anything goes to plus sign will be on top. So x cubed times y to the 4. Anything goes with the minus sign will be on the denominator. So z squared. Okay? So if I got another one, subtract 5 log base 2 of w. Then you're going to have one more term right here, minus log base 2 of w to the 5th. And of course, we'll do a minus right here, w to the 5th. Then you put w to the 5th in the bottom right there. Okay? Just show you a little trick to help you to work with log quickly. Because later on when you guys move on to calculus, you're going to need those skills, the technique to work with the bigger problem. Okay. Try another example. This one is going to be a little bit more complicated. Still combine the logs together. Okay. How about this? ln of x over x minus 1 plus ln, this is ln, of x plus 1 over x, and then subtract ln of what? X squared minus 1. X squared minus 1. Now, question asks you to simplify, combine all 3 logs together, and then simplify your answer. Okay, so I see what? They are ln, means what? Base, log base e, right? So I follow my formula that I learned before. Anything with adding will be products on top, and with subtracting will be on the denominator on the bottom. So this is what? ln x, oh, it's going to have a big fraction. X over x minus 1. That's the first one, times x plus 1 over x. Okay? So this whole fraction right here is one factor on the top. Whole fraction right here is another factor on the top. and then minus is going to be denominator, so over what? X squared minus 1. Now I claim that we can actually simplify the problem a little. We still got the ln right here. That x, going to cancel with that x. So my numerator will be x plus 1 over x minus 1. And my denominator, I can actually factor this out. X squared minus 1 is x minus 1 times x plus 1. Okay? And we can actually simplify this a little bit more. This ln, right? X plus 1 over x minus 1. Right? And the bottom is x minus 1, x plus 1. Divide by a factor means multiply by the reciprocal. Okay? So 1 over x minus 1, x plus 1. Think of it this way. And then we can simplify something in here. X plus 1, x plus 1 cancel out. So this is ln of 1 over x minus 1 squared. Okay? Just practice, do little by little. We don't have time to practice all the exercise in your homework in your textbook. So I'll just choose some examples and put on the board. Please practice more, do your homework, okay? Then you have the question, let me know. Okay. Try one more example that I see is in your homework. I mean in your textbook. Maybe not in your homework. Alright, I see this. Log, so they don't indicate the base number, which means that's base 10. X squared plus 2x minus 3, x squared plus 2x minus 3 over x squared minus 4. This is my first log. And then subtract log, again is base 10. X plus 2 over x squared plus 7x plus 6. X squared plus 7x plus 6. Okay? And they ask you to combine the two logs together and then simplify your answer. Okay? So let's first of all combine the two logs. I have a log, subtract a log. If I put them all together, it becomes log of x squared plus 2x minus 3 over x squared minus 4. This is the first log, right? Over x plus 2 over x squared plus 7x plus 6. You see? Anything with positive sign for the log going to be on numerator. And subtract the logs. If you combine it, becomes one log. Whatever inside will be a denominator. Alright, now you have one log, and I claim with this you can simplify more. And it's a fraction, divided by fraction means multiply by its reciprocal. This is what? X squared plus, oh, I forgot the log outside. Log outside, x squared plus 2x minus 3 over x squared minus 4. And divide by fraction means multiply by its reciprocal. So what? X squared plus 7x plus 6 over x plus 2. Alright, and I think that they give you some quadratic expression right here is factorable. So let's try to factor everything out, see if we can simplify more. X squared plus 6x, plus 2x minus 3 is x plus 3 times x minus 2, I think. Minus 1. Check my algebra, minus 1, yeah. And then the bottom, x squared minus 4 is x plus 2. X minus 2, and then for the second fraction we got in here x plus 6, x plus 1 over x plus 2. I cannot simplify anymore, so I will leave it there. Okay, actually you can combine x plus 2 with the x plus 2 right here as x plus 2 squared, but that's all I can do. So this is one log of all the factors. Okay. So you guys see that with the log, hopefully you guys get a hang of it. We have a big log, we can decompose, we can break it down into sum or difference of small logs, and the other way around, we have how many combination of small logs. You can put them all together, make a big log, and then simplify. Okay. And let's move on to the last section about the log function. We'll be talking about solving the equation involving the logs and the exponential functions. Okay. We're going to work in a bunch of exercises. I'm trying to give you as many examples as possible. Hopefully they're going to help. Okay, let me look at an example. Let's start with easy one. It's all solve x, okay? 6 for 6, solving log equation. If you want to make it as continuity of our work and make it like item number 4, okay? Solving log equation. Bunch of examples. All solve x, okay? Solve for x. We have this. So how about the first one? First example. Make it extremely easy. All right. Log base 6 of x plus 5 equal to log base 6 of 11. Oh boy. So you have left hand side is log base 6, right hand side log base 6. Okay. So we'll come to what we learned before. The number inside, which is x plus 5, is going to be equal to 11. So x equal to 6. Okay. There is one thing that's very important when you guys solving for equation involving the log that we haven't mentioned before. Recall that the probability of the log, say, or the domain, is going to be a positive number, right? We learned that. So one condition that you make sure that you guys are going to know is what everything inside the log. So in this example right here, x plus 5, the whole thing is going to be a positive number. Whatever number inside the log needs to be a positive number. So make sure that when you solve the log equation, after you have an answer, you try to plug it back and make sure that the numbers inside are positive. Say later on, let me try to explain what I'm saying. Later on you have this. You have an equation, log base 3 of x plus 7, okay? And you come up with like two solutions. X equal to negative 8, x equal to negative 4. And I claim that negative 8 will not be a good solution because when you plug an x equal negative 8 right here, negative 8 plus 7 is negative 1. So we cannot have a number inside the log equal to negative, not even 0. Okay? But negative 4 is good because negative 4 plus 7 is what? 3. Number inside the log is 3. Positive number is good. So this will not be a good solution, but this is going to be a good solution. You guys are going to see that in the next couple examples. So this is very simple, easy equation, so you don't have that problem yet. Let's move on. How about this? 1/2 log base 3 of 4 is equal to 2 log base 3 of 2. Okay? Now, not just through x, I copied it wrong. 1/2 log base 3 of x equal to 2 log base 3 of 2. Now, you don't have just log, but you have a number in front of the log. So before we can make the number inside the log equal, and we have to take care of the exponent. Right? 1/2 in here, bring it in, becomes exponent. So this is log base 3 of x to the 1/2, which is another way of writing square root of x. Okay, equal to log base 3 of 2 squared. You see, 1/2 right here, you will bring inside the log, becomes exponent. Okay, 2 outside right here, bring inside the log, becomes exponent. And now you got log base 3 of something equal to log base 3 of something. We okay to say that x to the 1/2 equal to 2 squared. Okay, so this is square root of x equal to 4. You square up both sides, you got x equal to 16. Okay. And 16 is good, positive. Right? Now let me move on to some exercises. This is more complicated. Okay. Solve for x. And this. log base 5 of x plus 3 equal to 1 minus log base 5 of x minus 1. Log base 5 of x minus 1. Okay, equal problem. Well, you have log, you have number. First of all, I'm going to group all the logs on one side. So I'm going to add the log base 5 of x plus 1 or x minus 1 on both sides. So I got log base 5 of x plus 3 plus log base 5 of x minus 1 equal to 1. You see what I've done from the first line to the second line? I'm adding log base 5 of x minus 1 on one side. That's it. Okay? So that I got all the logs on one side. They're all base 5, so I can combine the two logs together. So according to the formula that we have, log base 5 plus log base 5 equal to log base 5 of x plus 3 times x minus 1. And I multiply the thing inside. And then the left hand side going to equal to the right hand side, which is 1. Now I'm going to use our definition. Log base 5, this is the base number of something equal to 1. This is the exponent. This is the base, right? It means what? Base 5 raised to the first exponent will equal to whatever inside the log. That means x plus 3 times x minus 1 equal to 5 to the first power. Alright, which is 5. And then I can solve x from here, no more log. This is x squared plus 2x minus 3 equal to 5. So x squared plus 2x minus 8 equal to 0. Quadratic equation. Let's see if we can factor this out. 2 is plus 4 minus 2, right? So x plus 4 times x minus 2 equal to 0. You have two solutions, x equal to negative 4 or x equal to positive 2. Okay? Now, you really have to check, see if any solution is not working. X equal to negative 4. Negative 4 plus 3 right here. You plug back to the original equation. Negative 4 plus 3 is negative 1. You cannot have log base 5 of negative 1. That's undefined. So this will not be a good answer. What about 2? X log base 5 of 2 plus 3 is 5 is good, right? And this is 2 right here. 2 minus 1 is 1. It's good. Actually, log base 5 of 5 is 1. Log base 5, this is what? Of 1 is 0. So this is 1 minus 0 equal to 1. So really, this is a good solution. So really, you have to check. After solving, you see in this example right here, you have like 2 possible solutions, but only one works. Okay, let's try another one. Log base 1/3 of x squared plus x minus log base 1/3. This is 1/3, okay. Of x squared minus x equal to negative 1. This is my number 3 right here. Let me rewrite it. Okay, so now I see what on the left hand side I got the difference of the two logs, the same base 1/3 equal to a number. I can combine the two logs on the left hand side together. So I got logs base 1/3 in here. A log subtract a log, I know that I have a fraction of x squared plus x over x squared minus x is equal to negative 1. Alright, now I have log on the left hand side equal to a number on the right hand side. I'm going to use our definition. This means what? The base raised to the exponent equal to the number inside the log. Okay. So what? X squared plus x over x squared minus x is going to be equal to base 1/3 and raised to the exponent negative 1. Exponent negative 1 means what? You're going to have the reciprocal of 1/3, which is 3. Okay. So I see that actually I can factor out something on the left hand side. Factor the x out, I got x plus 1. Bottom is x times x minus 1 equal to 3. X can be cancelled out, so x plus 1 over x minus 1 equal to 3. Multiply both sides by x minus 1. X plus 1 is equal to 3 times x minus 1. So x plus 1 is equal to 3x minus 3. Okay. So add the 3 on both sides. I got 4. Okay. X plus 4 equal to 3x. Add the 3 on both sides. Okay. And then we'll subtract x on both sides. I got 4 equal to 2x. So x equal to 2. And keep in mind that you almost there, but not complete the problem yet. Make sure that you check to see those number of words. Okay. X equal to 2. And I plug it in. 2 squared is 4 plus 2 is 6. Yeah, good. X here is 2 squared is 4 minus 2 is 2. Yeah. So we have positive logs. Should be right. All right.